Hello. So under geometric progression, that we need to know is we have about four things. One is the nth term. So the nth term for a GP is given by a r to the power n minus 1, where a is the first term in the sequence, where r is a common ratio, okay, where and n is the number of terms, term. Now, how do we find the common ratio? Let me start from there. It's called common ratio because it's the same. If I have 1, 2, 4, 8, okay? If this is a GP series, okay, GP sequence, let me say sequence. How can you find common ratio? So I'll say find a common ratio, or B, want you to find the 6th term. Not, let me say find the 10th term. Okay. Now, how do I find the common ratio? Common ratio is given by second term divided by first term. Or you can get your third term, you divide by your second term. Or you can get your fourth term, you divide by your third term, just like that. In this case, we have 1, 2, 4, 8. This is our first term, this is our second term, this is our third term, that's our fourth term. We need to see that it's common. So r is equal to second term, it's 2. By first term, this will give me 2. I need to prove that it's also the same for this. Third term, it's 4, divided by second term, it's 2. My answer will still be 2. Let me also try. Fourth term, it's 8, and third term is 4. This will still give me 2. So my common ratio is 2. How do I find my 10th term? I know that nth term, okay, is equal to a r to the power n minus 1. So I'm saying that I'm finding the 10th term should be a. A is the first term in the sequence, 1, times r is 2 to the power n is 10, remember, minus 1. So this will give me 1 times 2 to the power 9. So you can punch your 2 to the power 9. That's 512. So we'll say 1 times 512, and this will give me 512 as my 10th term. So that's how you answer for a 10th term. Another part is the sum of nth terms. The sum of nth term of a GP, remember it's the GP, is given by sum of nth term is equal to a, open brackets, can be r minus 1, r to the power n, divided by r minus 1. You can only use this formula when r is greater than 1. Good? Or you can use this Sn equal to a, open brackets, 1 minus r to the power n divided by r minus, 1 minus what? R. You can only use this when your R is less than 1. Very less than 1. Let's use this example. 1, 2, 4, 8. Let's find the sum of the first 10 terms. So sum of the first 10 terms given by A. Since we know that our R first, you need to find your R. And you know that our R will be equal to 2 divided by 1, which will be equal to 2. And we know that in this case, R is greater than 1. So we know which one to use when R is greater than 1. So I'm saying S10 is equal to, so we know which one to use is that one upper there. So A, R to the power n minus 1 divided by R minus 1. This will be A is the first term, 1, open brackets. R is 2 to the power n, remember, is 10 minus 1 divided by R is 2 minus 1. So what I'm going to do is I'll say 2 times 2 to the power 10, sorry. First, I know that 2 minus 1 is just 1. Let me just evaluate on top. Now remember we have 2 to the power 10. 2 to the power 10, it's 1024. Now remember there is minus 1. We're saying minus 1. So we have 1023. So we have 1 times 1023. So when 1000 times 1 is just 1023 divided by 1. So the sum of the first 10 terms will be 1023.